After we thoroughly inspected the master cylinder that we removed from our Ford Pinto, we decided that its condition was questionable, and we purchased a remanufactured unit from our local auto store. Whenever we have any doubt as to the condition of any of the brake system components, we replace them without hesitation. The safety is well worth the small expense. The master cylinder is then positioned against its mounting brace, located on the upper left corner of the firewall. The holes are pre-punched, so it fits right into position. 3/8 of an inch diameter by 1.5 inch long bolts with flat washers, lock washers, and nuts are then inserted through the holes on each side. We do not fully tighten the bolts until the pedal assembly has been installed. The two lines that go to the brake differential valve are the same ones we removed from our Pinto, and after thoroughly inspecting and cleaning them, we connect them securely. We have to bend these lines slightly as the position of the master cylinder in relationship to the differential valve is different than it was on our Pinto. Since we have decided to use old-style custom gauges in our new 1929 Mercedes SSK replica, it is necessary to install a new water temperature and oil pressure sending unit in the engine. These sending units are furnished with the gauge set and are installed very easily. After we remove the original Ford sending units, we install the new oil pressure sending unit in the upper hole located in the cylinder head on the left or driver's side of the engine. We tighten these securely, being careful not to strip the threads. Normally, we use a piece of Teflon tape or liquid Teflon sealer, available at auto supply or hardware stores, when making any threaded connections of this type. Our new gauges will now connect quickly and easily and operate properly. The motor mount adapter brackets that we removed from our Ford have been cleaned and painted. We simply position these in place against the mounting plates on each side of the frame. The holes in the adapter brackets are aligned with the pre-punched holes in the mounting plates, and we insert the bolts and nuts we removed from our Pinto. The appropriate tools are used to thoroughly tighten the bolts. We had the rack and pinion steering gear assembly thoroughly inspected and all worn parts were replaced. Then we painted the entire assembly. Now we'll place the rack against the front of the Ford crossmember. We'll use the original Pinto bolts and nuts to secure the assembly to the chassis, passing them through the crossmember, then the rack and pinion. Normally, we insert the bolts from the rear and install the nuts on the front against the rack. In order to film this assembly, we are doing it in the opposite manner. However, we will simply flip the bolts around so that they go through the crossmember from the rear. Depending on the year and type of the Ford rack, we either find 2 or 3 bolts. The crossmember will accommodate both configurations. We use the appropriate socket and ratchet and tighten the nuts firmly. Later, we will use a torque wrench and tighten the nuts to the original factory specifications found in our factory service manual. After we have completed installation of the rack and pinion, we move to the driver's side of the passenger compartment and install the Pinto brake pedal. Because of the different types of brake pedals used by Ford, we find a number of different holes in the pedal mounting bracket. In addition, it may be necessary to modify the pedal slightly for comfort. We wait until after the seats have been installed before any modifications are made. After we have chosen the appropriate hole location, we slide the original bolt through the bracket and pedal from the passenger side. This will enable us to remove the bolt when the body is placed on the chassis. We then secure the assembly with the original nut. At the same time, we place the master cylinder rod along with the brake light switch on the stud located on the brake pedal arm and secure it with the original retaining clip. Now, we can tighten the master cylinder fully and check the pedal, making sure that it moves freely. Our Ford steering column has been cleaned and painted, and we're almost ready to install it. First, however, it is necessary to cut 3 inches from the tip. We measure and mark the column and use a hacksaw to make the cut while the steering column is secured in a vise, or we have someone hold it for us. The column is placed in position under the mounting bracket that is part of the steel tubular frame. The holes in the Ford mounting supports are aligned with the holes in the frame mounting bracket. and 4 3/8 of an inch diameter by 1 1/4 inch long bolts with flat washers, lock washers, and nuts are inserted through the holes. Once again, we could use a longer bolt here if we wanted to. The appropriate tools are then used to tighten the column, and the ignition lock faces the passenger side of the chassis. We have now completed installation of the steering column. In order for us to connect the steering column to the rack and pinion assembly, we need to fabricate an extension, as the original Ford column is too short. We referred to the instruction manual and followed the details precisely. We use a 30-inch length of solid 3/4 inch steel shaft and cut it according to the instruction manual. Then we have a notch machined in the piece so it fits into the factory Ford steering universal joint, and we secure it with the original hardware. A top-quality universal joint with 3/4 inch bore diameter connects the two shafts together. We drill through the holes located in the universal joint through the shaft and secure with a grade 8 bolt and nut. Then we will have the piece welded for added insurance. A top-quality 3/4 inch self-aligning pillow block bearing is also obtained and will be utilized. Alternatively, a complete extension is available from the factory. When the extension is completed, we give it a thorough coat of paint. The nylon bushing will be used to seal the hole in the firewall. The extension is now ready for installation. Before we can fit our new extension to our chassis, we must bolt the Ford Universal to the rack and pinion. We have thoroughly inspected the rubber coupling disc. If it were worn or loose, we would replace the entire unit, as the coupling disc is riveted to the flange of the Universal. We slide the flange at the lower end of the Universal onto the splined shaft of the rack and pinion and secure with the original Pinto hardware. Later, we will use a torque wrench and tighten to original factory specifications. Our steering extension can now be positioned in place. We slide the upper end of the extension through the hole in the firewall and into the steering column shaft. We have placed the pillow block bearing on the lower end of the shaft, and we insert the machined tip correctly into the end of the Universal using the factory bolt and nut to pin it in place. Next, we slide the pillow block bearing into position against the frame mounting support plate that is part of the chassis. The nylon bushing seals the passenger compartment from the engine compartment and is held in place with two metal plates that are bolted together through the firewall. After all pieces have been correctly positioned, we use our electric drill with a 3/8 inch bit and drill 2 holes through the mounting bracket, using the holes in the pillow block bearing as a guide. 3/8 inch diameter by 1 1/2 inch long bolts with flat washers on both sides, lock washers, and nuts are used to secure the pillow block to the chassis. We use the appropriate tools to tighten the assembly. We drill a hole through the steering column shaft and the upper end of the extension inside the passenger compartment and secure the column to the extension with a grade 8 bolt and nut. Later, before we drive our finished car any distance, we will have this piece welded for added safety. Strut brackets come with the assembly kit. We simply place the brackets into position against the inside of the frame rails on each side of the chassis. 4 5/16 of an inch diameter by 3 inch long bolts are passed through the holes in the frame and strut brackets and secured with flat washers, lock washers, and nuts. We pass the bolts through from the outside for appearance, and we are using lock nuts in place of lock washers. The appropriate tools are used to tighten the brackets. Next, we will secure the Ford metal bracket that holds the rubber brake line. It goes to the rear brakes on the left side of the chassis. Placing the bracket in position against the chassis, we mark 2 hole locations and drill 2 7/32" holes through the inside of the frame rail. We secure the bracket with 1/4" hex washer head self-tapping screws. The rear brake hose was thoroughly inspected. Had we found any signs of wear or deterioration, we would have replaced it with a new hose obtained from our local Ford or Lincoln Mercury dealer. The rubber brake line is then connected to the bracket and retained with the original Ford clip. Then we attach the threaded fitting at the end of our new rear brake line that we installed earlier to the rubber brake hose and securely tighten the 2 lines together. After we have secured the rear brake line, we move over to the gas tank. We have purchased 2 foot lengths of 5/16" and 1/4" inside diameter rubber fuel hose from our local auto supply store, along with 4 stainless steel clamps of the correct size. We cut the hose to the correct length, slide the clamps over the hose, then slip the hose ends onto the fittings on the tank and the ends of the metal fuel and return lines. The fittings on the metal fuel lines were removed by cutting the flares off the ends. The fuel line clamps as well as the fuel return hose clamps will now be tightened securely. Moving to the front of our chassis, we are now ready to install the engine and transmission. Here we have a type of engine lift that can be rented from most local rent-all stores, along with a hydraulic floor jack. We've securely fastened a chain to the front and rear of the engine, making sure that the chain is of sufficient strength to support the weight. Many engines will have engine lifting hooks. These are really L-shaped brackets with holes through them. A chain is passed through the holes, or a hook is attached. Either way, the important thing is to have a chain that is of sufficient diameter and strength to support the engine, and that the chain is securely fastened. Slowly, we lower the engine while we push it to the rear, guiding the transmission through the cutout in the firewall. This is not a difficult job, and while having someone to assist us would be helpful, it really is not necessary. A little patience is all that's required. Although this is the most convenient type of engine hoist to use, there are other types which work just as well. We can use whatever is available, as long as it's sturdy and intended for the job at hand. We want to engage the motor mounts attached to each side of the engine to the Ford through bolts that will pass through the holes in the engine adapter brackets that we bolted to the chassis earlier. We use our floor jack to elevate the transmission at the rear. Prior to purchasing our donor car, we had the engine completely inspected and any questionable parts have been replaced. A remanufactured alternator has been bolted to the engine and all of the electrical components have been checked.